Okay, so today you're going to learn a little bit more about the structure of the ATP molecule, the really important molecule for cells because it's basically the cell's only way of getting energy. Remember, a cell cannot use glucose directly for energy, that it takes the energy from glucose during cellular respiration, breaks that glucose down, and stores that energy in a molecule of ATP, which acts as like a little battery for the cell. And the cell can then use that energy anytime it needs to simply by removing one of the phosphates on the ATP molecule. So in Lab 13, you're going to learn a little bit about the structure. Now you're going to get a page of cutouts. So there's a step in the lab where it says to trace this. You don't have to trace it. You're going to get a separate page with cutouts so you can just cut them out instead of tracing and cutting them out off of that page. And then once you do, on step 9 through 11, it tells you to build ATP. So once you get to steps 9 through 11, you're going to build ATP. And this is how you do it. This is how you put those pieces together. You start out with the ribose and the adenine, and you put those together like that. It's very similar to the labs 6, 7, and 8 that we did where we had to remove the H's and the OH's and make water molecules in order to assemble our molecules. On the other part of the ribose, you're going to put the phosphates. And you'll have to take an H and an OH off of each phosphate except for the last one. The last one you will just take the H off of and leave the OH on. And that's ATP. The A stands for this part of the molecule, adenosine. Adenosine is made up of adenine and ribose. And then the phosphoric acids, or the triphosphates, there's 3 of them. 1, 2, 3. And that's ATP. Now what do we do with the leftover pieces? I think you know the answer. You make waters out of them. And if you've done it right, you should have 4 waters. Okay? Now you don't want to tape these down yet because you're going to continue on in the lab, and in part B it says to change your ATP to ADP. And it's very simple to do that, guys. All you do is remove that phosphate. And now you've made ADP, adenosine diphosphate, with 2 phosphoric acids. And when you remove that last phosphate, that's how the energy is released. By breaking this bond, you release the energy that is stored in the ATP molecule. The ATP molecule, remember, has those high energy bonds. It's going to store a lot of energy in those bonds. Okay? And then in part C, it says to change ADP back to ATP, and that's real simple. Just put that phosphate back on. And remember, this is how the ATP molecule works. It's like charging a battery on your cell phone. When it's ATP, it's fully charged, it's full of energy. Then you use your cell phone, and as you do, you're breaking off that phosphate, releasing energy so you can use your cell phone. By the end of the day, your battery needs to be recharged. So you plug it in, and the energy from plugging it into the wall and the charger goes to putting that phosphate back on. The next morning you get up, your battery's fully charged again. So that's how ATP and ADP function as a battery that can be charged over and over and over again. Good luck with the lab.